This problem asks us to write the name of the ionic compound. So they're giving us the formula and we need to write the name. In all of these examples, all of these compounds are ionic compounds that include polyatomic ions. So right now we're naming ionic compounds with polyatomic ions. Whenever you have a set of brackets in the problem, you always know that your polyatomic ion is going to be inside those brackets. So that can help us give us a clue to identify where the polyatomic ion is. So for in this example, we have Mg that comes first. So on the periodic table, that is a metal, which is magnesium. If it's ever a metal, you just put the name. Magnesium is our first word. Oops. And then inside the bracket comes our polyatomic ion. So HCO3, what is that? Well, we can look on our data booklet. If you're in BC Science 10, then you can look on your BC Science 10 booklet on page 5 is where your polyatomic ions are. And HCO3 has listed, where'd it go? There it is. It has listed two possible options. It's either hydrogen carbonate or bicarbonate. So we can either call this magnesium hydrogen carbonate, or a second option is to call it magnesium bicarbonate. Either one of those options is correct. So now for the next problem. The next problem, notice that it starts with a nitrogen. Nitrogen is a nonmetal, so that gives you a clue that you're starting not with a metal, but with a polyatomic ion. So we need to identify what our polyatomic ion is. If it ever is the thing that comes first, the only positive polyatomic ion is ammonium. So notice that we have NH4. That represents ammonium. So that's going to be our first word in the name. And what's left is OH. Since that's two things, it's going to be another polyatomic ion. And if we look on our polyatomic ion chart for OH, its name is hydroxide. Oops. Hydroxide. So NH4OH is, we recognized NH4 as ammonium and OH is hydroxide. So that makes the name. The next one we have, it starts with CS. If we look on our periodic table, CS is a metal, it's cesium. So we'll put that first. And all the rest of this is what is left after the cesium. So if we look on our polyatomic ion chart, that is CH3COO is the polyatomic ion acetate. So that would be our second word in our name. So this is cesium acetate. For the last example, it starts with ZR. Let's look on our periodic table, see if we can find if ZR is a metal. And it is. It's a transition metal. It is zirconium. ZIRCONIUM. And because it's a transition metal, it could have more than one charge option. But if you look on your if you look at your periodic table, it only has one option as 4+. So we don't have to put a Roman numeral since it only has one charge option. The next thing we need to look for is, because we have this set of brackets, we know what's inside of it is going to be our polyatomic ion. So we look on our polyatomic ion chart for NO2, and we find it to be nitrite. Nitrite, which is very similar to NO3 being nitrate. So be careful to look at those subscripts correctly and find which one that you are looking at. And whatever subscript is on the outside of the brackets for the polyatomic ion is not going to change the name. It's only what's on the inside. The outside is determined by the charge of the opposite compound. Okay, so I hope this video was helpful for you. If you have any questions, feel free to leave those in the comments, or my email is located in the description if you have something that is difficult to write in the comments. Also, I'm leaving a link to the BC Science 10 data booklet with all of the information about the periodic table and the polyatomic ion chart that I used. I'll also link the BC Chem 11 as well, because you'll have similar problems in BC Chem 11. Thanks for watching.